First of all, we need to record. Here we go. Yes. Hello, everyone. Welcome to our ASCILITE Learning Analytics SIG webinar. So today, really excited to hear from Roberto Martinez Maldonado. He does very exciting stuff, I think. And I'm sure all of you are interested in finding out more about the work that he's been doing. So today, Roberto, you have 3 short stories to tell us, is that right?
Yes, exactly.
Yes, wonderful. Instead of giving an intro to you, I think I will leave that to you. How about that? So you can shape your own story. Let's go with that.
Yeah.
So over to you, Roberto.
Awesome. Yeah, well, thank you very much, everyone. Thanks so much also for the opportunity for the ASCILITE SIG to give this talk. And but especially to you guys who are online at the moment. So, well, as the name of the seminar hints, I'm gonna talk mainly about physical spaces and how Learn Analytics can be applied, or some suggestions, and also some actual examples of the kind of things we have been doing. And I'm also going to talk a little bit about data storytelling, which is also a novel approach that is being borrowed from the general data science to tell stories with data. So I would like to just briefly introduce myself, although I know some people who are online, but I currently work as a full-time researcher at KIC, which is Connected Intelligence Center in UTS. And my background is in human-computer interaction and engineering before doing research. And before being an educational data scientist here, I was with Professor Peter Goodyear at Sydney Uni, where I got a bit of enlightenment, I think, from education. And well, this talk is going to be a bit, I was going to talk about data, right? So just as a warm-up, let's talk about the amount of data we have available. You know, like this is the last stat that I could get, which is that about 2.5 quintillion bytes of data are generated every day. I think it's more at the moment. I've seen other numbers, and I was curious about this quintillion, which I never used in my life before, which is lots of data, lots of data. And yes, I can tell me if you have any question at any point. I'm going to tell 3 little stories at some point, and I'm going to indicate if you have any question, you can respond it then or at the end. So yeah, feel free to interrupt me. And continuing with this warm-up about data, you know, it's like we have a spike of data in the last years. In the last 2 or 3 years, more than the 90% of the data has been generated, and this number is scaling up. So this is no surprise that we have lots of data. But if we roll back a few years ago, this is before I was born, John Naisbitt was already talking about that we have lots of information, but we are starving knowledge. And knowledge is quite different, quite important, because we can make decisions based on knowledge, but not necessarily based on just data or information. Or we can take the wrong decisions, actually, if we don't know really well what the data is representing. And I also, part of my introduction, I also teach data visualization in the Master in Data Science. And to my students, I always use this, I tell them this metaphor that data, imagine that they are like oysters. And well, this is not the best picture because there's lots of oysters and they don't look necessarily pretty, but if we start opening some of these oysters, in one of these oysters, in about 10,000 oysters, we're going to find a pearl, and the pearl is very valuable. It's actually very expensive. And the metaphor is that if the oysters are the data, the pearl is an insight, and an insight is knowledge, and we can actually make better decisions if we get actually this pearl, and that's very valuable. In terms of Learn Analytics, maybe I don't have to introduce Learn Analytics because it's the SIG on Learn Analytics, but let's also learn from the past. This is the first definition of learning analytics that was in the first conference, which is now 8 years ago, 7 years ago, which was based on, we're talking about data about learners and trying to extract these pearls from the data to understand and hopefully optimize learning. I would say optimize the opportunities of learning if we talk about learning design. So this is the original definition of learning analytics, although in the last 8 years, learning analytics has been expanding and exploring different contexts, and sometimes it's not necessarily data about learners, but also about the teachers, about the classrooms, about the institution, about the learning design. And the purpose is not necessarily understanding or trying to optimize learning or whatever activity, but sometimes also to provide feedback, to other stakeholders, and so on. So, okay, yeah, here we go. And something that's important to understand as well, if we step back and look at this field of learning analytics and other related fields like artificial intelligence in education, educational data mining, and other disciplines that are also data-oriented or supported by data. We have this spectrum of actual activity. If we are not considering data, just actually where learning happens. We have at the right of the spectrum fully online systems where everything, all the actions are mediated by computers. And the more we go to the left, we have on the other extreme fully face-to-face classrooms and physical spaces where no technology, or at least not much technology, is used. And we have a lot of different scenarios with hybrid environments in between, where technology is sometimes used as support, but not mediating all the interactions between students. So we can see more examples without needing to do a survey, but most of the examples are on the right, going towards the right of the spectrum, in fully mediated or partly mediated learning scenarios, because logs of activity are easier to obtain. And this has been historically the case, from intelligent tutoring systems where we get the logs and we have all this data. What can we do with this data? And not much is being done on the left side, or is less and less. So I've been very interested in physical classrooms since I started to do some research. And part of this research, it starts with Google, and I Googled some who else is doing classroom data and things with classroom data. And I found lots of these pictures there, which I think this one is from a primary school in the States, where this is actual classroom data, and classroom data has been used since the beginning. It's different kind of information, and in this case, in some schools, they have this dashboard with different information, data, and comparison charts. But we're also talking about different kind of data, like what is the utopian scenario? Well, this is the scenario envisaged since a few years ago, before learning analytics even was used as a word, which was to model the student and then understand what are the weaknesses or the opportunities for individual learners to improve their skills, provide support, like kind of individualistically. Also, we have other scenarios where maybe we can help the teacher to know more than what the teacher can know if he's just in the classroom, things that happen online, etc. This is kind of a scenario. So, or having like a dashboard for each student. And people have been discussing about this in different learning scenarios. So, is this where we are going? So at some point, probably we need to also focus on the left side of the spectrum, right? So it's what happens in the classroom. The classroom probably is not going to be abandoned, although there was predictions that obviously were not true, that everything was going to be online and moving things online was going to be the future for expansion. But lots of universities and also schools are valuing the importance of the physical, the face-to-face. So why is this classroom space important? That's a question. Why to focus? Why to focus on the actual space? And well, one of the first things I was saying, the high investment in new learning spaces is being witnessed in Australia is quite big. And it includes all levels, from K-12 to this picture from UTS, and this is new spaces that invite the students to actually understand the value of being physically present in a university. And especially UTS has a bet for the physicality, and they have very interesting spaces. But this is happening in other universities, as I've witnessed as well. And this also includes libraries that also invite students to stick around. But why that investment is happening there? Well, this is also something that's happening in offices, in different spaces where we have these workplaces with all these different tools that are not necessarily technological, but technology is there. So even if we don't want, technology is going to get into these spaces. And it's happening even in what we can say traditional classrooms. Kids are coming with their devices, and sometimes the teacher forbids the kids to use them, but sometimes they are embraced and be used as part of the practice. So technology in different ways is getting in all the spaces. But it's also, there are some spaces that cannot just move to the online world, like physics spaces, like physics labs or chemistry. And in higher education, we have lots of these big labs where, I mean, the skills that need to be learned are intrinsically physical. And some of them are really involving the development of physical skills, like medical education, or the skill is completely involves the psychomotor realm, that is like dancing education, etc. So just to wrap up this introduction before we go to the three little stories, I would like to quote Professor Peter Goodyear, who I was working for a couple of years, three years ago. And this quote, someone quoted him one of his talk. He said, like, even online learning doesn't happen online, actually. It happens where the learner is. So it's not where the learner is not. So in this case, this little figure on the right bottom of the slide, we have three girls working with a computer. And if we just don't take a holistic view, if we have a fancy model of the learner, this learner is going to be very biased. It's not considering that next to that girl there's other two girls that maybe are hinting, or just the sole presence of them changes the whole learning situation. So if we don't consider this whole holistic perspective into learning analytics, we are always going to probably be taking the wrong decisions and never get into those pearls. So these three little stories are actually what it starts to become something like a perspective of the physical, something I call translucence classroom. So I'm not going to talk too much about that, but that's kind of the idea. How to understand what's happening in the classroom, make it more translucent? Well, maybe there are three levels at least. One is to look at the classroom as a whole. Then if there are small groups or different ways of organization, ways in which the students organize themselves, well, maybe it's a small group or group analytics. And then we have the individualistic level, let's say. So I want to explain this in three different examples, and these are very, very new, so they are not extremely mature, because this is very new research and ongoing research. But this is coming from some old work, so I like to start with the old work because it's the inspiration. And this was some work I was doing when I was doing my PhD in Sydney University in a human-computer interaction lab, where the intention originally was to, okay, what happens if we use these interactive tabletops that at the time were really new. And well, it's a device that is not easy to find other classrooms. So the innovation was just of how can we use this new technology. But at the same time, we can learn from the past and say, well, other devices like even televisions in the 80s were new devices introduced. And there was lots of promise, but in the end, it's how you use the tools. And that's the important thing. So instead of trying to look at the novelty of using tabletops, the idea became to, okay, let's use these tabletops, but let's use them as sensors, let's say. And why sensors? Because in the classroom, the teacher can see many things. You know, teachers have an extra pair of eyes, as I always say. But there are things that the teacher not necessarily can see. So how can we use these tools, these tabletops in this case, and enhance these tabletops with some sensors like a Kinect to provide this extra pair of eyes to the teacher? And that's what we did. The idea was to automatically detect what was happening in each group. So it was 5 tabletops or 4 tabletops in a classroom. So the tabletops were collecting information about the task that the students were performing. And we could provide in real time with this dashboard, very simple dashboard to the teacher. The teacher could hold or just leave somewhere in the room. And this idea was the initial idea of making this classroom translucent to provide some support for orchestration, but particularly in terms of learning analytics for enhanced awareness. So we, beside the tabletops, we have all these architectures of the tabletops where the actual software was connected and there were Kinects on top of each so we could recognize who's doing what to some extent, and a microphone array either at the middle or in each tabletop to also get a bit of information about who's speaking. So to make the story short, we ran quite a few tutorials, real classes with a few teachers and quite a few students as well. And we developed in the end this dashboard that included orchestration commands, which were probably the favorite of the teachers. So the teachers could just tap these buttons and, for example, block all the tabletops, which is very simple. It's not analytics, but that helps the teacher to orchestrate the room. But we also provided like a visualization for each table. In this case, is number of touches on the tabletop, which is informative, but the teacher can complement with other information. At the top, we can see a visualization of the lesson plan and how it is being enacted in real time. An alarm that warns the teacher, oh, if you're behind the lesson plan. And some notifications like these rounded squares around these visualizations, the pink and the red one. And when the teacher would tap on those notifications, it would receive direct information. Now, in this case, the students were doing a concept map. And automatically the system would detect, oh, maybe this proposition in the concept map, like cognitive walkthrough, is a user method. This was used for a subject in human-computer interaction, actually. It would provide direct information to the teacher that the teacher couldn't easily see because the teacher cannot access 5 concept maps on the go. So this is also one of the favorite functions for the teacher, which is not the fancy analytics that we usually see, but it's just text. But it's other kind of analytics, other kind of feedback for the teacher. And we also explore how this data about the learning design, like in this case, would help the main teacher, the subject coordinator, to tune the subject for the next semester. In this case, the first series of lines are the design for a 1-hour lesson. And below we have 14 tutorials all agglomerated. And we can see that the second activity in blue was shortened, 11 minutes for the second activity when the plan was 15. So more for performance assessment. And this helped the teacher in one of the classes to say, oh, next semester probably I need to tweak the introduction to maybe flip the first part of the instructions. So students, so we make the most of the time. So it's different kind of analytics. Another kind of analytics was to manually see how the teacher behaved in the classroom going from one table to the other after looking at the dashboard. And we generated this kind of graph of states where we could see, for example, there is no arrow between the teacher looking at the dashboard, the central node at the bottom, and the green table to the up left corner. So this was interesting. It's like, oh, why you didn't visit the green table? Because they seem to be going fine, although they were the less visited by the teacher. Well, so it was very interesting to start seeing this kind of information coming from very simple analytics. And one of the teachers mentioned, oh, it would be good if I have an alarm that says, oh, I'm spending too much time with the red table because they engage more, because they ask more questions. That was very interesting. And that started, coming now to the future or to the present, that started to trigger some questions. In one of them was, okay, how the teacher actually learns what's the best strategy to be moving from one table to the other, and what happens if we are in a normal or more regular classroom. And after some literature review, we found lots of guides, especially non-research sources, especially for teacher education. And this is one of the books which is very prescriptive, and it actually provides some numbers about the distance that the teacher should keep between students and themselves, and how the students, for example, shouldn't stay in the green area, which is a bit far from them for a long time, because then the engagement starts to go down. And this is some research actually pointing at that. And it suggests how the teacher should move. And now we were wondering how the teacher learns these, especially in higher education, where sometimes there's no training for this kind of how to move in the classroom. And we have these new, lots of new innovative classroom dispositions. Like this one in the picture is one of the classrooms I use for teaching, and lots of people in the faculty of IT in here use for teaching. And we go to another discipline, they have totally different furniture arrangements and different devices, and each building is different. Each classroom sometimes is very different. So we decided to, now that we have technology more available, we got these ultra wideband positioning tags, which in the time that we were doing the tabletop classroom study, they were very expensive, and now they are less expensive. And we can try the teacher in the classroom, and we have now a project called Where is the Teacher? And the idea is to, okay, what can we do with this data? We can understand how the teacher is moving. If we have lots of these tags, maybe how the students are moving. But now we are focusing on the teacher. But more interestingly is if we know where the students are as well, roughly speaking, in each table in this, like in this previous picture, we can also calculate the time that the teacher is dedicating to each team and write some alarms that you can see on the right side of this mock-up of the first dashboard we have. We have now an actual version being deployed in the next weeks. And for example, we can highlight that team 5 and 6 are not being attended that much, and teacher may can take action. Obviously, coming from a human-centered design background, human-computer interaction, this is the first mock-up offer to some teachers, but they are already starting to say, like, yeah, well, how do you calculate what is, how these alarms are being triggered, or how not to interrupt the class, and all these design questions, which we are in this what we have in this the rest of the year. We're co-designing this to make the most of it and not interrupt the orchestration load of or increase the orchestration load of the teacher. But there are other applications, and actually this is one recent paper in 2017, and these researchers in Toronto are tracking the workflow of clinicians, nurses, and doctors in simulation scenarios, which looks something like this. They are doing this manually, actually, but they are finding that this data is very useful to consider changes in the furniture, for example. In this case, there's simulations, but knowing what's the distance that the nurse need to cover is critical, you know, in an emergency response scenario, for example. And there are some couple of people in hospitals already interested in this technology, and so we are applying it to these kind of scenarios, which I'm going to explain now in the second little story, and also can be applied for teaching. So if you have any question, I'm happy to respond. Otherwise, just can continue to the second story. Good. So the second story is about going down into one level of granularity. You know, the classroom can be very noisy, and actually we are thinking on looking at the noise of the classroom. Yeah, how much, that was this one question about, and now, yeah, using it as a transition, how much did the monitoring interrupt the flow of teaching? For the tabletop classroom, for example, well, this is a whole new classroom, so obviously the whole teaching was different and new for the own teacher, and so it's very hard to measure. For the second project we're running at the moment, the monitoring of where the teacher is, it doesn't interrupt the flow of the teaching because we are just tracking and the teacher wears one of these tags in the pockets. We did some studies I'm not presenting here just because it's very new in physics classrooms, where we track the teacher, two teachers actually in this physics classroom with lots of objects, and the students are actually doing experiments with tangible objects. And the two teachers in the classroom are moving around, and we collected all this information that we are processing at the moment. But for them, we didn't present any interface. So the actual tracking didn't make any difference in their usual behavior, unless that they feel that they are being tracked, but they were like, oh, I forgot about this, it's just a little badge. So we were just there as observers. This is something that happens in normal pre-service education anyway, as most of you would know, I'm sure, more than me. And there's peer observations of how people teach and all that. So it's an actual practice. And definitely another skill that teachers need to learn is, or how to incorporate into the practice is how, if there is data and we can find pearls, or the teacher can find pearls from these data, insights, how to make sense of them, which is also part of a participatory design process, which is involve the teacher in, instead of making decisions for them, it's like, okay, what kind of decisions the teacher can make, part of the teaching inquiry. Moving towards a smaller level of granularity is what happens when there are multiple teams in the classroom, what happens at that level. So we are not focused only on the teacher, but on the students themselves. And one scenario, one little story is in healthcare simulation classrooms that were very interested in that. And this came also as an inquiry from the teachers in health who said, okay, if you work with tabletops and you have this kind of analytics, we have this problem here. We have, instead of tables, we have beds, and there is a mannequin there, and we can get some data from the mannequin, but we would like to know what's actually happening around this mannequin. So we open up this project called Learn Analytics Meet Patient Mannequins, which we presented in last year, I think. And the first time we went there, we saw that it was a very chaotic classroom with many things happening. It's a classroom hospital simulation. And we decided to, okay, well, let's give it a go. Let's see what kind of data we can get about what's happening around the mannequin. So we can collect some information from the mannequin, and we added a depth sensor, a Kinect, to know where the nurses are around the mannequin, and a microphone array to see if we can capture any noise that can be meaningful depending on the positioning of where the noise is coming from. So with the Kinect, we could see a table like this one, like a screen like this one. In the bottom right of the slide, we can see what the Kinect can see. In this case, it's like 7 students, and there is actually the teacher marked in yellow, which the Kinect cannot differentiate who is who. But we can get bodies around the mannequin, which is course level data. But when we took this raw data, which you can see for two groups on the left most column in this table, this is the raw data, and it's like, oh yeah, what's it saying? And the other three columns marked as T1, T2, T3, we have the whole simulation divided in blocks of 20 minutes. The whole simulation was 1 hour. And just by plotting this data, converting these dots into some 2D map, we started to see a little bit of patterns. This is two groups in the same classroom. And we could see that for the first group A in the first row, the nurses stay at the base of the bed because they have notes for the handover, and they actually went to the to attend the patient until T3, until the last bit of the simulation. While for group B, it was the kind of different. From the beginning, there was nurses next to the patient, they were engaging, and we obviously we took observations, and it was very interesting. But if we just present this as we did, we presented this information to the teacher nurses, they were asking more questions that getting any insights from it. They were like, okay, yeah, this is interesting, but what were they doing? Why were they there? Are they actually speaking not with the patient, between themselves? Are they confused? Many questions. So we also explore other things to give more answers than questions. So for example, again, with learning design idea, these are two timelines. In these timelines, T1 is a teacher, and is the way the teacher follow up the enactment of the classroom, and T2 provided more information for more time for the simulation, which is the blue bar. So we can see a big difference here. When we presented this information to the main course coordinator, it was surprised. It was like, why T1 was spending almost 1 hour in instructions and inductions, which that was not part of the plan. The main professor was T2, the one in the bottom. So these are all the kind of analytics that start to also help the teacher to ask questions about why this is happening in the classrooms. So now we're working based on this knowledge gain on a new installation, which is trying to get a bit more data about what's happening in these small groups. And for example, now we have this indoor localization track, so we can know who is where and doing some actions when. So it's kind of starting to create logs as we would get from an online system, and also physiological wristbands, because the stress of the nurses is something that in the academic literature is there very explore and sometimes unexplored topic as well. So we started with the initial prototype, putting all this information together. The nurses got a bit scared with all this information, so we ended up, because it's including many things that a checklist of things that happen on the right time, if there was a stress level spike. But we conducted some students participatory design sessions about the kind of information they would like to actually see, because otherwise it's too much. And they were talking about critical incidents, especially if things that happen when the positioning is somehow interesting for them, and the communication with patient and other nurses is critical for them as well. And if they are doing a CPR, information about how well they're doing. And surprisingly, although the teachers and researchers in health, they are interested about the stress levels of the nurses themselves don't want to know about it. As you can see in the sixth bar chart, they're actually not that interested. So these help us to understand, okay, what things can we capture? Obviously, we would like to capture communication, as you can see in the left bottom corner. The students would like to see about things about communication, at least who is speaking with who, and maybe the content. Obviously, this is not it's a big challenge in face-to-face environments, but this helps us to come into another prototype. And this is something we're testing now with the actual students, and they are giving us very good feedback. It is more like a timeline, things from the epistemic dimension, things that are happening, when they're happening, who is doing these things, and also a bit of social feedback. And the idea is to provide this as a reflection tool after the nurses have done the simulation, so they reflect back. This is actually connected with the practice they do, the debrief. And there's very interesting discussions like around this hospital sim lab. And yeah, really, we'd be really happy to follow up on this project, share technology or lessons. Yeah. And it would be very something we're trying to do as well, as Wendy mentioned. There's people in a hospital interested in the positioning, like what happens if we change the furniture in a simulation-based environment, to try to understand what's the optimal way to position the beds, the different instruments, the trolleys, to minimize the time that the nurses and hospital doctors need to spend in reacting in different scenarios. So yeah, and the last story, and we're close to the end. This is a short story because we haven't done much into the individual level. This is one work being done by one of our PhD students in the uni, Augusto Santos, who is looking at these other kind of very interesting classrooms, which is also face-to-face, which is a classroom where students are learning to dance. Is what we call emotion analytics for social dance education. But at the moment, what he's doing is to creating an app which can be used by any of these students in the classroom or in their homes. And the idea is that it models certain aspects of the movement, although it's a model that is going to be incomplete because dancing is so complex. At least it can give, the idea is to provide feedback to the students about their rhythm skills. And he's testing this in a social dance environment where learners are learning to dance forró. I don't know if you hear about this kind of dance, but similar to salsa. I think salsa is more familiar for people. Forró is kind of similar, but at the same time, different. And we are looking at data, actually, not just at the dancing figures. And it's two sources of data. It's a very simple approach. So the idea is to that in the mobile phone there is an accelerometer, and the accelerometer captures these trends and movements of the student, and this is marked as this wave line in this slide. And if we have the information of the music, as we do, then we can put the beat of the music, which are the numbers 1, 2, 3, 4, 1, 2, 3, 4 is the beat of the music. And when we put this information together, it's possible to know if the movement of the student is following the rhythm of the music, and knowing if a student was doing right. Like for example, in the peaks marked as blue in this slide, the student was doing right, stepping in on the first beat, and stepping back on the third beat. But then in this case, there's a mistake. In the first beat, the student didn't step in the correct point, and you can see that as some problem in the time series. And then we can see that the student recovered, but it recovered in the third beat, which is a common mistake of beginner dancers. And the idea, yeah, that's very interesting comment. Here, the idea is that the student sometimes doesn't have enough time from the teacher. So you can see here is a small class actually, but from experiences of these PhD student, he's actually teaching up to 100 students, which makes this impossible to give personalized feedback about the dancing. So the idea is that the student can use this app at home to start to know about rhythm as an extra class. So yeah, it's very interesting, and this raises also comments about ethics and monitoring. So okay, let's wrap up, and just to also know if you have any question. So let's go back to the initial question, which was about space. Why is the space so important? Well, it's very hard to respond after all those comments about investment, but I think I would focus on other things, like maybe going back to the Peter Goodjar's quote about thinking holistically, where is learning happening actually, and how it's happening. So cognitively was originally the focus of most of artificial intelligence in education and data mining and modeling of the learner. It was very cognitive, create a user model of what the student has done, and that can be used, the behavior can be used as a proxy of the knowledge and learning, etc. There's lots of people also working on affective cognitivity and affective analytics, and obviously the social aspects of how people interact with each other, especially social networks, and this is very, very interesting. But also we have that the physical, actually collaboration and learning is multi-dimensional, and at least these 4 aspects should be considered when doing learning analytics, right? And we also probably need to be focused on the insights, which was also how we started, coming back to the oysters. We're gonna have lots of data, especially with all these sensors, and we can make wrong decisions and actually ethical implications of capturing this information that's maybe is beyond the learning, because we're talking about the physical space. So our future directions are into data storytelling, and this is the shorter story, which is something that we are just starting this year, which is, okay, why people in learning analytics are complaining already about dashboards? Is that dashboards are not working, and well, it's because many reasons. Can be also from interaction design aspects, and one of the future directions is like, why not taking a data storytelling approach and focus on the insights? And data storytelling starts with the graphs. We see lots of dashboards with graphs like the one on the left, and we have dashboards with lots of pie charts, and especially pie charts. If we go to information visualization, basic design principles, pie charts shouldn't be used if there are more than 2 dimensions being represented in the pie chart. So a pie chart is good maybe for representing male and female, and probably that's already incomplete already. Nowadays, we are conscious more about how to represent aspects like gender. So we are thinking in terms of design. We need to not just reinvent the wheel in terms of data visualization, and probably data storytelling is one of the promising approaches. So this means coming first to clean your data. So in this case, from the left, which is actually a graph produced by Excel and by many other visualization tools, to something a bit cleaner. And then going one step forward, which I'm going to have to jump to the last version of this visualization, which is, you can see in a book called Data Storytelling with Data, which is for the general data science, but it can give lots of information and opportunities for inspiration for learning analytics. And this is a proposed data storytelling visual where we don't focus on presenting all the data points, for example. All these data points, what is the insight? What's the pearl? So visualizations can become visualizations that communicate insights. In this case, pointing specific moments in time, like May, 2 employees quit in May, and what happened after is that the performance of the whole team started to go low. That's the insight. It's not presenting data, because others, emphasis, decluttering, and sending some information or hiding some information that is not relevant for the insight. So in a possible claim, we claim this is in a paper that is currently under review, that most visualizations in current learning analytics deployments are exploratory rather than explanatory. So an exploratory visualization is the one that invites to explore. And in information visualization literature, it says that you need to be specialized and trained to explore a data visualization. So we are sometimes asking too much to students and teachers to become data scientists, pretty much. This is one example, actually one of our studies. This is a visualization with lots of data about progress. It's just a timeline of progress in a setting of entity relationship diagramming, and how the solution of the students goes closer to the ideal solution. 100% is in the y-axis. But this requires lots of, like a loop, first of all. So there are some problems with the design, but also there's lots of data. And what to look at? What's the insight? So this is pretty much the data-driven visual analytics approach. We have data, we process the data, and then we have visual analytics. And this is a process proposed by a team in QU Leuven, that once we have the analytics, the student or the teacher raises questions, gives responses to those questions, and performs some action. That's the ideal scenario, but that's asking too much to the teachers and users. So this is a learning design driven data storytelling approach that we are proposing. We proposed this year in LAC 18, which is, what about using the learning design as a guidance to try to extract some these pearls, to understand what is a pearl. So try to start a rule, to develop a rule that when applied to the data, we can distill, okay, this was good performance, this is bad, this is an error, this is actually, this explains the data, trying to explain the data through data storytelling elements by emphasizing certain things or sending things to the background, as we say. So then the questions are also given by the learning design. And this learning design can adapt the visual analytics in a way that the teacher or the student gets responses already, gets insights. And these insights are already decided by the teacher or the learning designer who chose what's important for that lesson. So at the moment, obviously, how to operationalize all of this is a challenge, but we can go from this visualization that is more exploratory to this explanatory visualization, which is using the same data, but applying some rules. For the teacher, for example, it said student and scholarship are the main two entities, and they are marked as selected data points. First of all, the whole visualization is decluttered, so it's simpler. There is prescriptive title, which is already the insight. This is a high-performing team. The team was able to determine all main entities and all main relationships. And how do we know that? From the data. And there are some areas that can explain why there is no activity, like there's the reflection activity, that's in the learning design. There are some selected data points, and we hide the other ones that are not critical, like in this case, student and scholarship. And if there is a big trend, we can create a rule and create some text explaining, okay, this team improved the solution in a short period of time. And give some assessment, formative assessment. Well done, the team recognized important entities. So this is the idea of bringing these elements. It's kind of designing for storytelling. And we started to do some analysis, and I'm going to stop here, but we started to use, for example, eye tracker, which is also some interesting use. I was not expecting that the eye tracker could get this kind of information. If it's exploratory visualization, teachers tend to explore each data point, and if we actually have explanatory visualization, it goes straight to the text, and if the text is correct, maybe it's communicating insights. So, so to wrap up now, to finish, 2 items for future learning analytics agenda. It's more like a question than a suggestion, but let's see. The first one is embracing complexity. Coming back to that question is maybe involving the physical processes besides cognitive, affective, and social aspects that are being explored. And the last one is maybe focusing also on human factors, such as one approach can be focusing on extending on human-computer interaction information visualization insights to communicate data, communicate insights, sorry, not rather than data. So yeah, thank you very much. And these are pictures of some people involved in all these projects, past and future, so and present. So thank you very much. I don't know if you have any question.
Thank you much, Roberto, for that. That was a very rich set of stories right there. Just looking in the chat for any questions.
No, thank you.
Yeah, the comments coming in for just, sort of thanking Roberto. Yeah, I agree. This was a very useful set of stories, exceptionally applicable.
Oh, thank you. Sorry, I was a bit longer than planned.
Oh, not at all. That was great. That's it. Yeah, there we go. Judith has a question. How detailed can the motion detection be?
Yeah, that's a great question. That's related with technology and it's evolving every month. And action of hands, that's another great question. First, the motion detection. We've been trying different approaches. The first that we tried was with the Kinect, which is, let's say, very inaccurate because there is lots of occlusion. The Kinect needs to be in one position. It's very inaccurate, occlusion, noisy, and so it's an approximation. So we dropped that one and we started to use beacons, which are very cheap, and I think that's the future. So if you can check beacons, iBeacons, and all these kind of things. They are based on Bluetooth, but they are very inaccurate at the moment. They are like 3 meters. They have 3 meters of accuracy. So that means like the smaller classroom we're going to be working in this semester is like 5 and 8 meters. So it's like you can know where the teacher is if he's in this quarter of the classroom, but not where it actually is. So we are using ultra wideband tags, which doesn't use beacons, Bluetooth. It uses radio technology, and the accuracy, nominal accuracy, is 30 centimeters. So that's much better than 3 meters. And when we look at the data, it's like 40 centimeters every now and then, but it's really, it's really, really good. So we are using that kind of technology now, and very, very recommended. And we are very, you can also apply it to small group collaboration, not just to follow the teacher. So in small group collaboration, 3 meters, with 3 meters error, you don't know if the person is to the left or the other person, or they are close to each other, 6 meters away. But this technology we're using is 30 centimeters, is quite accurate. And I think technology is gonna get, there. Like each mobile phone is gonna have this localization. This didn't exist like 4 years ago, so it's getting there. And the other question is about the detection of hands. Yes, there's people, we have this kind of multimodal learning analytics. It was going to become a SIG, but we're in the process. So it's like a bunch of people we meet pretty much every year, and there's people working on posture, other people working on these multimodal selfies for individual tracking of dual eye tracking, and one person working with the hands, with the position of the arms. So we are not doing that, but I know if interested, I can put you in contact with exactly who is doing what. So just drop me an email and I can pass you his information. It's in Northwestern. Action of hands. And did students have any concerns with being closely monitored? Yeah, that's another great question, because this is critical. In general, learning analytics, ethics is a whole track in the conference now every year, probably 2 sessions. And ethical issues in data is critical. Is actually today in Australia, I think you just saw a tweet by the director of Simon Buckingham Chung, who's sharing this information about the Australian government to start to I think it's a consultation at Australia level about data science, data about humans, and yeah, it's a hot topic. And I think we need to carefully think about the physical space, because in online interaction, when the student logs in, we can say that all the actions done through the system are going to be monitored, and that's it. So the student consents for interaction with that system. Like if we go on Facebook and we don't read the small print, but we accept, we pretty much agree with whatever we share in Facebook. But if we go to another system, in theory, we shouldn't be tracked, although we are being tracked, and probably we sign for that as well. Anyway, but in the physical space, if we have a camera, for example, we can get lots of information, and some information that is not related with learning. So we need, I think we need particular guidelines. And something we are exploring, for example, is this classroom level analytics, where we don't identify what people are saying, or we don't capture video. So besides the movement, we are thinking on looking at the noise of the classroom rather than the voice or the content, more like the noise, the general, what's happening in the classroom level. Or instead of using a camera to detect where students are, we are thinking of using heat cameras, although they're expensive, or just the depth information sensing with other identification of people. So I think that needs to be clear and clarified with the students. Like, we're not capturing video, but we are capturing three-dimensional dynamics of the classroom. So yeah, that's a hot topic, and it's a question I cannot just respond in a single yes. But concerns, and at the moment we're not capturing pervasively. So all the students, well, in this case we are focused on the teachers, so teachers know, students would know, and I think some would have concerns, and those need to be clarified. That would be.
Thank you so much, Roberto, for sharing so much insight into learning analytics in the physical space, and including communication of data as well. I think there's a lot that we can take away from this and continue to think about. If you're all interested in learning more, Roberto has his link to his page there and his Twitter. Thank you so much, everyone, for your time. Thank you very much, Roberto, especially for your time and sharing your work here with us graciously. I'll end the conversation here, but just a plug for the next ASCILITE Learning SIG webinar. We are looking to seek contributions from doctoral students this time. So if you are a PhD student or know of a PhD student or supervising one, please get in touch with us if anyone's doing any PhD research in learning analytics, whether it's practice-based or purely sort of in the lab. We don't care. The wider, the broader, the better. All right, thank you, everyone.
Thank you, everyone. See you. Thanks for the opportunity.
Thanks, Roberto. Bye.
Ciao.